Now that we've seen how to add vectors and subtract them, we're going to see how to multiply them by a scalar. A scalar will just be a number that scales the vector. So let's come back to our swimmer. What if now the swimmer swims half as fast? Swimmer swims half as fast. Okay, can we recover the angle and the magnitude of his velocity with respect to shore? So let's see what that means. So initially we had vector s, okay, which coordinates were exactly 3 root 2 over 2, 3 root 2 over 2, okay, and the magnitude was 3, the angle was 45. And now he's swimming half as fast, so you have to understand that the angle is not going to change, okay? So when we're going to multiply a vector by a scalar, the direction is not going to change. It's the magnitude that's going to change. So here, half as fast means that its speed now is 1.5 kilometers per hour. So the coordinates here, okay, everything's being scaled by a factor of 1/2, right? So it's normal that the coordinates are just going to be also half as small, okay? So we're going to divide everything by 2 like that, okay? And that's going to give us approximately 1.06, 1.06. So this new vector, okay, we could give it a new name, but it's really half of s. We're going to note it like that, half of s. Okay, so definition, okay, if k is a scalar, so for us a scalar is just a number, and let's say v is the vector with coordinates x, y, okay, then k times v, the new vector k times v, is simply obtained by multiplying the coordinates of v by k. Maybe actually the arrow here should just go above v like that. K times v is just defined like that. Okay, so in our problem, right, remember we've got the shore, we've got the swimmer now swimming at with a velocity. So what's the difference between velocity and speed? Speed is the magnitude of the vector that represents velocity. Velocity includes speed and direction. So he's swimming at 45 degrees, and here there's water with a current that's 20. Okay, so remember this is 20 here. So the resulting vector is just this vector, let's call it v here. So in our case here, v, the resulting velocity vector is half the velocity vector of the half of the initial velocity vector of the swimmer, and now it's swimmer swimming half as fast, so it's half of s plus w. So this is going to be 1/2. Okay, I'll do it slowly again. So 1/2 3 root 2 over 2, 3 root 2 over 2, plus 20. Now, the definition says that the coordinates of the new velocity vector for the swimmer are obtained by essentially you multiply the 1/2 by every coordinate inside. So you get 3 over 2 divided by 4, 3 over 2 divided by 4. So this is what we had obtained here. Okay. And we add to this 20. Okay, now if I compute this using my calculator, I'm going to get 3.06 and 1.06. Now so what I have is essentially the effective vector is something like that with 3.06, 1.06, and now I'm going to get the angle and the magnitude of v. Now the magnitude is the square root of the sum of the squares of the coordinates. So that's approximately 4.18 kilometers per hour. And theta, theta is acute, so it's simply the arctan of b over a, or x over y over x, and that's approximately 19.1 degrees. Okay, so with respect to the shore, he or she swims at 4.18 kilometers per hour with an angle of 19.1 degrees. Okay, and now just to finish this up, okay, with something more abstract, let's say I give you two vectors, u and w. Notice we use a lot the last letters of the alphabet for vectors, except we don't use x or y because those are usually used for coordinates. So we use u, w, s, t, z. Okay, those are all good letters for vectors. And now I'm going to calculate 2u minus 3w. Okay, so that's pretty simple. So it's 2 times 1 minus 3 times 4 minus 3. And first of all, I perform the multiplications, and multiplication by a scalar is just multiplying the coordinates by that scalar, like that. And then subtraction is just subtracting the coordinates. Like that. Okay, so very, very simple. And that creates a new vector, of course.